I'm going to talk, I'm taking the opportunity to go back to a topic that I first looked at or started thinking about years ago and have not done much about. And that may be a signal in itself, and that's going to come as a question. So at the end, about whether or not this is worth doing. So that's actually my big request from you, is literally not just assessing measurement errors in poverty, in estimates of poverty dynamics, so transition probabilities, but how, whether or, assessing what Jenkins's take on this. The starting point is from my presidential lecture 2 years ago, which is online. It's still on YouTube, up there with Madonna and all those others. But I began riffing on a theme of measurement error, and basically this is continuing the riff on measurement error, but in different parts of the distribution. So I want to begin with perhaps a bit of repetition about why we should be interested in measurement error, and then get more into the poverty dynamics aspect of it. So, the very basic idea is that things like income inequality and poverty, which are cross-sectional pictures, and income mobility and poverty persistence, longitudinal indicators, that they're very important social indicators. And indicators of their importance are, for example, Eurostat's inclusion in its headline indicators. Many international organizations produce these indicators, including the World Bank, who's helped today, and so on. But an important thing to note is that a lot of the estimates, including the official statistics on levels and trends of poverty and inequality, are derived from household survey data. And we know household survey data contain measurement errors of lots of different kinds, and that means that the estimates of interest, our social indicators, may be biased both in levels and in trends. And although most official statistics are cross-sectional, there can be biases also longitudinally. Now, the way I've begun thinking about this, this wasn't a conscious plan, but it seems to be where I've ended up, is I've been thinking about research, thinking about measurement error rather differently in different parts of the distribution. You could think about it at the top, the middle, and the bottom. And today's talk is going to be about the bottom, but other bits are going to be relevant to my topic. So a bit of background. So we're going to walk through briefly top, middle, bottom, and then go to what I'm actually going to talk about today. So, and each of them going to think about the problem that's focused on, how biases have been assessed, and the main implications or findings, results, and so on. So at the top, fairly obviously, two main sorts of problems are potentially there. One is that there is higher unit non-response rates by rich people. So basically, they don't want to participate in the survey. And that even if they do participate in the survey, there's underreporting of income by them. So how do we know this and how do we sort this out? The main approach has been by using administrative data from income tax records instead of the survey data. That's the most famous, let's put it, it's the most famous way at the moment, and clearly the top income shares literature out there associated with Atkinson, Piketty, and Size is an important part of that. What might you do, given the information from administrative data of various kinds? First of all, you might reweight the survey data to account for the differential non-response, the first problem. And speaking of the person we were speaking of, very dear Martin, he was associated with an important stream of work with co-authors. He had a couple of papers about how to reweight things using the primary example with US CPS data. Actually, I think a lot of their results were because they were using US CPS data, but that's an issue for another time. The other thing you might do is to do with the underreporting issue is to replace the very top incomes in the survey using tax-based data-based imputations, and you can do this in a non-parametric way or a parametric way. So essentially the idea is you align the data in the survey and the tax data according to common definitions at the individual level, and then at the top of the distribution where you've underreported data, you use mean group imputations from the tax data assumed to be right into the survey, and then recalculate everything. I've done quite a lot of work on this with others, including Nicolas Hérault, who is here and did a lot of the work. The other thing you might do is replace and reweight. Do both of those things. And in fact, this is a very old idea, and many academics don't know that British civil servants were the first to do this and started doing it in the 1990s. So the official British Poverty Series, which also produces inequality estimates, actually also already did this from 1992 onwards. Of course, there are some more famous work more recently, and we honored yesterday in the General Assembly a prize-winning paper by Blanchet, Flores, and Morgan, which was about replacement and reweighting in a sophisticated sort of way. So this is, but again, both of these approaches are trying to get at the problems focused on. And what are the headline implications? Well, fairly obvious. You basically want to fill in the top. And so what happens if you put more weight at the top? You're going to get higher inequality levels, estimates. What happens to trends? Not always clear. But basically you get more inequality. And there's a big literature on that. When you look at the middle, things are done a bit differently. And I'm talking about it as the middle because the people in the middle, their principal source of household income comes from employment earnings. So the way in which people, economists and statisticians, have thought about measurement error is to think in terms of the so-called classical measurement error, which is basically there is both over-reporting and under-reporting, which is different from at the top, where there's, think about it as systematic under-reporting of various kinds. In the classical model, you have errors with zero mean and a positive variance, with an important complication that people have talked about, known as mean reversion, which is where the measurement errors may be negatively correlated with your true earnings. So what that effectively means in practice is that you get over-reporting below the mean and under-reporting above the mean. Okay, so how do we know this? How can we try and calibrate these sorts of models? Answer, again, is administrative record data. But what's done here is that there is typically one-to-one linkages between individuals, their survey reports, and other reports on their earnings. And in fact, here's where error might come in, is that employers are making those returns, typically as part of the social insurance returns to the government, or whatever agency looks after social insurance. So you basically put one against the other. In the first generation literature, in the first bullet point there, effectively assumed that administrative data were error-free. And that's a nice situation if that's true, because you can then basically put all the measurement errors in the survey and you can work out its properties fairly straightforwardly. Complication, of course, is that employers may screw up too. So you can allow for errors in the administrative data. Those are what I call second generation studies. And there's a whole series of papers now actually moving beyond the first generation studies, which are pretty much all for the US, with one exception, Austria, but a small number of studies for a range of countries. For example, Fernando Rios-Avila and I have got a series of papers exploiting a particular instance in the UK where we could do this one-to-one linkage. And what do we find? Typically that in the survey estimates of earnings inequality tend to be overestimates of true inequality, and all these second generation studies, which are as soon as you allow for measurement error in the admin data, mean reversion disappears. So what that means is you end up with classical errors in employment earnings. So essentially you get the measure is equal to signal plus noise, and hence the result about variances. So that's in the middle. What happens if you go down the bottom? Well, here the principal source of income in many countries is from transfers from the government, benefits, cash benefits as I'll call them, and typically people talk about under-reporting of benefits at the bottom. How do we know this? Administrative records again. Now, we don't typically have the one-to-one linkages in the same way as we do with employment earnings, but you can work things out using the aggregate under-report from the survey compared to the the agency that gives out the benefits. You can use models. You can use the fact that particular benefit eligibility rules say that some people should only have particular sorts of amounts, and so on, and do the work. And there's quite a lot about that. And the implications or findings have typically been that survey estimates of poverty rates are overestimates if you keep the poverty line changed. Okay, so the reference point has changed. And the effects on trends are less clear. And I guess some of the most path-breaking work, at least in the US, is done by Bruce Meyer and colleagues at the moment. In the UK, the Resolution Foundation has done some important work on this. And that is they all come out with the bit about survey rate estimates of poverty rates are overestimated. Now, this is, I should say that this is not, without controversy. And if you want to know something about the controversy about, and again, coming back to this theme of measurement error being important, go to Demography in 2020 and read the interchanges between Sullivan on the one hand, Sullivan's a mate of Bruce Meyer's, and Brady and Parolin about what's going on at the bottom. I won't go into that contentious debate here. Anyway, so I've said admin data, admin data, admin data, but what happens if you haven't got admin data? And also the other thing about the studies I've been talking about is that they're either cross-sectional studies or they're time series of cross-sections. So what are you doing if you want to, without longitudinal data, and you're interested in longitudinal perspectives, of which, of course, an important longitudinal perspective, either income mobility or looking at poverty transition probabilities. And they're clearly important. Peter Lanzhou, who is up on the front bench here this morning, he with Haiyan Dang have got an important literature about estimating poverty transition probabilities using synthetic panels, which is the case when you have no longitudinal data. I'm a bit further along in the sense I'm going to have survey data, but trying to assess whether or not the transition probabilities are okay. But because we've got no admin data, we've got no truth reference, some sort of modeling is going to have to take the place of the realized truth. So the starting point for my focus on the bottom today is whether or not the latent class modeling approach is any good. And I'm focusing on a latent class transition model here because that's the most important one that has been used in this area today. So we're basically thinking about measurement error as a misclassification of individuals into the wrong poverty state, which seems fair enough. And in fact, when I first started thinking about this a couple of decades ago, I wrote to Paul Allison, who is the leading quantitative sociologist who works on these sort of things, and I tried to talk to him about some things, and he said, nah, these latent transition models, they're the ones how things are. I haven't spoken to him again recently, but this is the area in which we're in, and in particular, I've focused my attention on a paper by Richard Breen and Palamasio, BM, if I will. And that's quite nice for this society because it was published in the Journal of Economic Inequality in 2004, a long time ago, but there's not been much work on this. And they used one of these latent transition class transition models, a latent mover-stayer first-order Markov model, and applied it to ECHP data, so essentially European data for four waves. There's been a load of other applications, not many by mainstream economists, but there are also, for example, models of unemployment status out there that also include these sorts of approaches. And so I'm going to be trying to assess this BM model using a different approach. It's very preliminary, as you should see, and I'm going to be asking you whether or not I should bother to continue further. So what is this BM approach? Oh, there's the model. Make a load of sense? No. Okay. So essentially, think in their situation, they've got 4 waves of panel data, and we're having transition tables between each pair of successive years in the waves. So we've got 2 by 2 tables. 2 by 2 gives us 4 cells, 4 years, 4 times 4 is 16. So essentially, we're modeling counts in this sequence of matrices which tell us whether or not somebody is poor or not. And so essentially we're modeling counts, broadly speaking, and then you can think of that funny right-hand side there as being split into a structural model and a measurement model. Structural model and measurement model, this is their labels, not the way economists would think about structural models. But essentially, the structural model is defining the process by which things happen truly over time. So it's basically characterizing the initial poverty state probabilities in wave 1. So those are the deltas. Let's see if this... I'm not sure I can aim this very well. The deltas. And then there are the probabilities of transition between poverty states subsequently. Those are the taus. And you can see they're up there too, but they're also conditioned, as we shall see. So it's a first-order Markov model, but it's also supplemented by allowing for unobserved heterogeneity, and that's of a particular form, very popular in this area, called a mover-stayer form that I'll come back to. And those are related to the probabilities pi. So basically, this is the probability of whether or not you're a mover or a stayer. Okay, so if you're a stayer, to give the headline away, if you're a stayer, where you are at the beginning is where you're stuck forever. And basically what then happens is that the combined structural model is a mixture, in the statistical sense, of a first-order Markov model for movers plus persistence in the initial state for the stayers. That would be fine, but on top of that, we've got measurement error, and the way in which they think about it is that poverty status is not observed very well, and the misclassification is characterized by probabilities, these rows. So basically, it's summarizing the chances of being observed poor or non-poor, conditional on being truly poor or non-truly poor, and so on. So you can think of rho for reliability parameters, summarizing if it's equal to 1, then there's no misclassification. And of course, that expression up the top would be a lot simpler. Okay, so what happens next? Well, how do we fit this model? First, we've got to identify it. Okay, we haven't got a lot of data. We've got a lot of parameters. So what you basically have to do is make some restrictions. Essentially their best fitting model, and the one I'm going to go forward with, it's the one that people have used most before, is that you allow the poverty transition probabilities to change from wave to wave. Okay, so that the concepts of substantive interest are allowed to change. On the other hand, for movers, their misclassification reliabilities do not vary. So in a sense, the measurement process is staying the same over time. Stayers, as I said before, basically their true transition probabilities are fixed by definition, and there's no misclassification for them. So really quite strong restrictions that are in their best fitting model. And just to bring out the sorts of things that they're finding. They're using standard income definitions, same as Eurostat. It's what's used to assess the at-risk of poverty statistics in the EU, so a 60% of contemporary national median poverty line. And the headline finding, if you will, is, quote, mobility and poverty transition tables is overestimated by between 25% and 50% if measurement error is ignored. Oh, that's a lot. I mean, you'd expect, standard thing, overestimation with measurement error, but I think this is a big number. Now, they do say that the differences across the countries, there are some, and if you look at the true transition probabilities, the true according to their models, then there's less cross-national variation than the observed estimates and can change the rank ordering of the countries. But what's going on and where is the source of the problem? The source of the problem is that, as they say, quote, much of what appears to be exits from poverty is actually measurement error. In the ECHP, the poor are usually badly identified and certainly much less accurately measured than the non-poor. So essentially, a problem at the bottom is with the source of the problem. Let me give you some examples of this, and let me just focus, given time, focus on the table here. What we've got here is, so we've got the state at T is, we can have either observed estimate, or the latent estimate. This is the one fitted from their model, the true estimate. And then we have the three pairs of years going for, because we've got 4 waves. It's old data, as you can see. And so, for example, the row probability, the chances of being non-poor in 1995, given that you were not poor in 1994, is around 91%, and so on. Standard reading of a transition probability table. Now, the key thing in terms of the assessments and underlying the sorts of comments that they were making, this is focusing on the UK, by the way, is that if you look at these rows, what you want to compare is, for example, not the observed number, 91 here with 92, and you can see that there's not much difference there, okay, for those numbers. And of course, 9 is just 9 plus 91 makes 100, so we only need to look at one number. But the worrying thing, and this is where their stuff is coming from, is to compare this 1/3 with this 1/6. Okay, that's where the big differences are coming about, and the fact that it's coming from exits from poverty to non-poverty, or equivalently up here, the difference between 66 and 84. Big numbers, right? Yeah, okay, so it's pioneering, but you know, we've seen that model. Is that an adequate description of poverty dynamics? Don't know, but it's the best one that they've come up with so far, and people have talked about this. They don't talk about initial conditions. Econometricians think about initial conditions quite a lot. Don't think about it. What about time homogeneous measurement error? Well, no serial correlation in measurement errors here, or misclassification errors. Or the thing that actually got me started in this area was the size of the difference between those estimates. Frankly, when I first started thinking about this, I was the person who was the architect of the net income files for the British Household Panel Survey. Okay, so I had vested interest in producing estimates of poverty dynamics. And I thought, my numbers aren't that bad. And so I put it another way, I thought I'd better investigate this. So this is where the initial motivation comes from. But my more fundamental critique of this whole area, and where I've started thinking about this, is really whether or not the measurement error problem is something about misclassification of poverty status. I mean, is poverty a clear-cut state in the same way as something like unemployment or disability, perhaps? Because the choice of the poverty line is arbitrary. You know, you talk to people about and say, European poverty line, 60% of contemporary national median income. And they go, what? Why 60%? Why not 57.5%? Or, other things like that. So basically, I'm a bit uncomfortable with saying that there is some latent or true, which is the way in which it gets interpreted, some latent binary poverty status. What I'm much more comfortable with is thinking about there actually being measurement errors in income itself. So I think that we should then think about what are the implications for poverty dynamics, and they will depend on where you choose the poverty line. So I think we should think about the dynamics underlying and the problems arriving in income, onto which we can then put one or loads of different poverty lines and see what happens. And then how might you think about biases if you take this a particular approach? Well, of course, I'm not first in this area, and a first approach that you might take has been led by Dan Millimet and his colleagues, where you take a bounds approach. So the idea is non-parametric, so-called partial identification rather than point identification approach. What you do is derive bounds on transition probabilities, and you can do this even if you've only got 2 waves. I haven't done it yet, it's sort of on the agenda. But basically what you do is make a series of assumptions about the misclassification error process and the mobility processes. Now, these guys argue that these assumptions are fairly transparent, and I've listed them here. And if just reading them, I don't find them entirely transparent. But nonetheless, if you work hard at their papers, the point is that by making a sequence of stronger and stronger assumptions, and in the standard sort of Mansky type way, you can get the interval estimates for these estimates can be narrowed. And they've done it for India, for example. I think it's pretty cool, but nonetheless, I think their bounds are still pretty wide, and I haven't done it yet. Okay, so what else might you do? Well, you might become a pure econometrician, as Guy Lee, who is a PhD student of, I think, of Ritter and Strauss. There are two papers that are almost identical, that are only changed by these people. But the idea is sort of similar to what we had before, in the sense that we have a structural model, in the sense of a model of how true income evolves over time. But on top of that, you place a measurement error model, which has time invariant and time varying components. And they fitted that to Korean panel data. And one paper does it with per capita consumption, the other does it for per capita income. And the measurement errors that they try and identify here, the process refers to errors in income per se. So this is closely related, by the way, if you're familiar with the literature by Blundell, Pistafari, and others looking at income risk and so on, where they use model assumptions to back out measurement error variances from transitory error in their models. So basically what these guys do is use their fitted structural model to simulate error-free income in every year. So the idea is you've got true income, and then you get error-corrected poverty transition matrices. You compare them with what you observe, and actually what they find, quite similar to Breen and Moissio, is that the error-free poverty exit probabilities are much lower than the observed exit probabilities, which is sort of nice. So I'm sort of stealing ideas from everywhere. And what I want to do is, where I'm starting is in exploring is a simulation-based study. Okay, we don't know the truth, so let's make up the truth, is what we're going. So what I want to do is specify, first of all, models that are of income dynamics and measurement error that are in the spirit of Lee and his colleagues, but everything's in a simulated world. Okay, so, and I'm going to use a measurement error that's based on the measurement error in the model, in the middle literature that I talked about before. Then I'm going to, after specification, secondly, I'm going to calibrate the models using parameter estimates from the previous literature. And why not? I'm going to turn Simland to make it similar to the UK, country where I now live. So we'll use that. And same idea, we're going to compare what you come out, what the model tells us what the true transition probabilities are and the observed ones, and look at the difference and see, having fitted the BM latent class transition model to the same data, what happens. Okay, so I'm going to walk you now through the models and the calibration and so on. I'll do it relatively quickly. How much time have we got left? About
15 minutes?
Yeah, so, okay, so the model is pretty simple. It's based on the one that they do. It's basically, why anything with a star on is true, or otherwise known as latent. So it's basically a first order autoregression. So a key parameter is this gamma thing. But you can see that there are, and that there are, in terms of the time series process, there's also a time invariant individual effect, the alpha, and a transitory, so an individual specific idiosyncratic error in each time period. First assumption is that the model is in its steady state, so everything's turned over time, and basically an assumption of log normality. So that means that the initial distribution of income is normal with mean and variance as set out like there. So already we're seeing parameters appearing, and we're going to be calibrating those later on. So how do you go further? So if we're following Millimet and others, you set the fixed effect as drawn from a uniform distribution, and it has a particular variance, of course, and the idiosyncratic error is also normally distributed with a mean 0 and some variance. But of course, you've got this model, the steady state assumption, you can play around with it. And because it's log normal, everything's characterized by the mean and the variance, so that you can derive expressions for the mean. Expectation of the log of true income in any given period is given by a particular expression, and so you can turn things around the other way and work out what A hat is in terms of other stuff, and similarly with the variance. So as it says at the bottom, if you've got some values for the mean and the variance, and these parameters summarizing the rest of the process, you can derive other stuff. Okay, so you don't have, you're modeling assumptions, reducing the number of assumptions that you have to make in the calibration. So very much like the sort of structural models that we had from Raquel Fernandez the other day. Model plus calibration is what we're doing here. Measurement error, again, very simple, but it corresponds to the model that underlies the measurement error in the middle stuff that we have before. So log of observed income now is equal to true income multiplied by this rho parameter, which you can think, plus an idiosyncratic error, which also has a time invariant individual effect plus an idiosyncratic effect. The key thing is this mean reversion parameter rho. If you have a classical measurement error model, then that's equal to 1. If you've got mean reverting error, rho is less than 1. Okay. Following Millimet and others, you can define a term which is realized measurement error, which is this mu it term, given a particular expression. And then you can derive expressions for the eta it term in terms of other stuff, okay, in terms of means and variances of this thing, rows and so on. And then you make assumptions about these are fairly standard, basically the measurement error of the two fixed and the random components are both normally distributed. So essentially a mixture of those two, which depends on this other psi parameter. And then what that means is if you've got values for these means of realized measure and variance of realized measurement error, values for these two things, you can derive all the other moments. Okay, so how are we going to calibrate things? Where are they going to come from? So clearly, choosing the mean and the variance of these two things is going to determine the shape of the log normally distributed marginal distributions of true income, inequality rates, percentage poor, etc., etc. But you still need values, in fact, at least 6 values to calibrate the model. So I'm going to follow Millimet and others, and instead of choosing the variance of realized measurement error directly, I'm going to choose a reliability parameter because it's easier to find estimates in the literature of reliability. The other thing you have to watch out for is that you can't just choose any parameter that you like. You have to choose them to ensure that variances are positive. Okay. So what I've put up in this table here is, for reference, what Dan Millimet and his colleagues chose for those various parameters. And on the right-hand side, I put my numbers. And the numbers are not exactly the same. Why are they not exactly the same? Well, Dan's work was to do with annual labor earnings for US men. The Gini in his data were simulated data were around 0.6. That does not correspond to the Gini for UK household income, which is around 0.3, 0.35. So, and also there's the point that varying the choice of reliability and rho is much more consequential than choosing the gamma and the kappa. So basically I'm going to fiddle around, going to have a leading case, which is the 0.81, and then just show you also what happens with a variation from that. As I said, it's preliminary work. So basically I'm calibrating to the UK, Gini 0.35. Poverty rate that comes out initially is around 0.2, 1/5, and the transition probabilities, as you'll see, are plausible. Some of Millimet's choices weren't feasible in the UK for those constraints that I'm talking about. As it happens, some of the numbers that I'm choosing here and Millimet we're using also correspond to numbers in the Lee and colleagues' papers, and happily also correspond to some of the stuff that Fernando Rios-Avila and I were getting for employment earnings in the UK. So what you do now is, okay, we want a 4-wave panel to set it up like BM. We set 5,000 households, because that's basically what these household panels have. Because we want to set steady state, you simulate dynamic processes for 100 periods, and then use the data for the last 4 periods to ensure that you're in the steady state. Okay, so what that means is we get a Gini of 0.38, you get poverty rates of around 16%. For true poverty rates, the observed poverty rate is around 25, given a poverty line of 60% of median observed income. Okay, because that's what real life would be like, setting the poverty line in terms of observed income. And of course, the simulated panel data are providing us, for every individual household in the panel, you've got a sequence over these 4 waves of whether or not people are poor or non-poor, given their income and their poverty and this poverty line. Okay, so what we can do is now compare things. And in fact, the transition probabilities are broadly similar, and we get more poverty mobility in observed transitions than error-free transitions, which is expected, especially exits. But the latent probabilities differ from the error-free probabilities, and you get a big overestimate. So now we've got a table where we've got the same format as before, but now we have observed, okay, observed in SimLand, so it's made up, okay, error-free also in SimLand, but these are the true ones. And down the bottom is what happens if you fit their model to the observed data, okay? And again, you compare things, and basically across time it doesn't change very much. Why? Because we're in the steady state. And then you can compare these things. And again, all the action is not transitions out of non-poverty. It's essentially transitions out of poverty. But what you see here is, for example, that we get the qualitative result is what is similar as before. Okay, observed exit probability down here of just over a quarter. True one is 0.16, but hey, down here, you fit this to, it's really wacky, okay? It gets it wrong. Okay, so that's the bottom line. And there are basically, in the interest of time, I won't go into some more details, but basically, their model is overestimating persistence and underestimating the degree of mobility that's going on. Okay, is this just because of the way I've calibrated it? Well, not really. If you do it again with those changing these 2 key parameters, and I fiddle around with other ones, you can see, in fact, that again, that the observed and the error-free are much closer. Okay, they do better here, but hey, we're still way out. Okay, the bottom line. So that, again, this particular problem here. So overestimation of persistence and so on. So the implications here, we've got, so are they getting it wrong, inappropriate stuff, and to what extent are the answers depending on the specification model, the specification of the simulation model of the calibration. So essentially, I'm here asking you, is it worth carrying on exploring this stuff? I mean, what it doesn't do is provide a nice, easily implementable correction that the Breen-Marciot approach does. Because remember, they get true estimates. I'm only in SimLand and talking about the problems. I'm not sure. So I guess we'd also like to find out whether or not the BM approach is providing an upper bound approach. So in terms of, I mean, the real Achilles heel problem for the simulation approach is the model specification and calibration, but so how might that be developed? Clearly it's following what a load of econometricians have done already, but one thing you might say is, well, that guy talked about measurement error at the bottom at the beginning, and he's talking about poverty dynamics here, but he never incorporated that in his measurement model. So maybe what I should do is modify the measurement model to incorporate systematic underreporting at the bottom, okay, which the people who've worked with labor earnings dynamics have typically not done. And of course, playing around with different calibrations is important as well. Playing around with different poverty lines, after all, the poverty line is arbitrary. Does it make a difference? It doesn't make much difference between using a relative and an absolute line because of the steady state stuff we're in here too. The other important thing here is you might have said, oh, Jenkins said he was doing simulations and stuff like that, but I only did one simulation. And the process is, this is, of course, is stochastic, so you'd like to average across replications. So what we'd also like to do is add bootstrap standard errors for the transition probabilities. One, because the Breen-Marciot approach, at least in the software that they're using, because it uses an expectation maximization method, does not produce any standard errors. Okay, so bootstrap is an obvious way of going about that. So combining, taking account of simulation error, taking account of inference aspects as well, is an important next step. but that actually brings computational stuff. It can be fun, but it's also very frustrating. I've been doing stuff in an old free program called LEM, and of course in Stata, because you know I'm a Stata nerd. But there are issues at the moment that I haven't figured out about how you do the looping. And if you've got any tips, better tips about different software, I mean, people who do these latent transition models are often big fans of M+. I hate it. If any of you have tried to look at the notation that you have to use for M+, it'd be like Springer's new package that you have to use to submit to the JEI. It's terrible. Anyway, there are other packages out there that you might use, and I would be interested in your sharing your experience and so on. So just my final remarks is to say where I started is that measurement error is important, and it's important in particular for social indicators, the big social indicators of the sort that were talked about earlier today, and including poverty transition statistics. Ideally, I guess we would say, well, it'd be great to have administrative data linked to the survey data so we could do this properly, even if we could assume that the admin data were error-free, but that's not always the case. But as we have seen before, a lot of the admin data that are available so far are either for employment earnings or they're for benefits. What they're not for is household income, okay, where everything is added together. You have to be probably in some Nordic country, special case, where you're able to add everything together. But even then, part of the problem in the Nordic countries is many of them have gone entirely over to registers, and you wouldn't then be able to use to compare how the surveys are going. But anyway, I guess the initial result that is coming out from the work so far, preliminary work so far, is at least for poverty transition probability estimates, different approaches can give different results. And the leading approach out there so far, this latent class transition model that Breen and Marcio popularized, doesn't necessarily stand up relative to another approach if you believe this other approach. So I think given the importance of poverty persistence estimates, it's worth exploring the topic. Whether or not the way I'm doing it's the way to go, I don't know. I leave it over to you. Thank you.